Cool. 879 profitable schemes. There are GE people in a gang, and a list of various crimes they would commit, or they could commit. The I crime generates profit supply and requires group supply gang members to participate. If a gang member participates in one crime, that member cannot or can't participate in another crime. Let's call it a profitable scheme where any subset of these crimes that generates at least P profit, and the total number of gang members to participate in that subset of crimes is at most G. How many schemes can be chosen? Since an answer may be very large, return in modulo some number. And n is some small number. N is 100-ish. Hmm. Yeah, there might be a more efficient solution, or stuff that kind of use like probably like I mean, just guessing from my submission stats, probably something that uses like a way bigger memory table for whatever reason. Because apparently I used very few or not that much memory, so. Yeah, I mean, I think it's okay. I mean, if it's good enough, it's good enough for me. And I think also the other thing that I forgot to point out is that, of course, n is less than 10,000. You could actually literally just generate a lookup table and then answer any answer in that thing, right, for query in theory in future. But yeah, cool. Okay. Yeah, just back to this part for a second. Okay. Take a profit at least 3. You can take a profit at least 5. You can, as long as they commit 1. Ha ha ha. Okay. I mean, it feels like some kind of knapsack-y thing, maybe. But okay, let me reread this. Groups of I. Okay. So the first member takes 2. Yeah, I mean, I think this is actually straightforward. Sorry, I just have trouble reading this a little bit. Well, maybe I shouldn't say that. Maybe I jinxed myself. I feel like every time I say it's straightforward, and then I have a lot of issues for one. But yeah, I mean, I think it's just the subset of and the target along the way. So profit is the length of profit is up to 100. Oops, what's the target? P is less than 100. So yeah, so this dimensions are just GP, and then yeah, and then the n, where n is the number of crimes they're considering, and yeah, and n to the oops, was it n to the 4th? No, it's n to the cube. There's no because you either do a crime and you don't, and then that's it, right? So yeah, it should be okay. I'm gonna do it in C just to. I don't know. I just been doing things in C. Yeah, okay. I think the tricky thing is also knowing that yeah, I think the tricky thing for this one may be making sure your base case is right, because even though you finish something, you might have to keep going a little bit, or like you have to count the number of possibilities if you keep going. So yeah, okay, let me play around with that then. I think the dimensions. Okay. Oh, so this is the number of ways that you could do it, I guess. Well, it's just initialization, but okay. Calculate, what am I calculating for? Just T again, G people now. Okay, let's calculate how many ways that, given that your requirement is P, okay, and you start with none of the crimes. Okay. I think that's okay. Okay. I think that's. I have to set up some stuff. Yeah. Index of crime. Target kind of. Let's go target profit. Let's go numbers. Okay. Okay. If index is equal to n, then we return 1 if target is equal to 0. Otherwise, return 0, right? Because that means we have target left. Also, if target is less than 0, we set it to 0. That's essentially the same state. Okay, and then for each one, we either do this crime or we don't, right? Okay. Okay. Yeah, maybe on the interview I would have kind of not use globals as much, but yeah, I mean, maybe definitely. Index here should be the index of the crime that, like the index of the crime that you're considering. So yeah, so like in this case, it is the index to the suffix of profit. So if index is 0, that means you're looking at the 0th element of profit and group sub I or group sub 0 and so forth. I mean, maybe it'll become a slightly clearer once I type the next line out in a bit. But let me just get rid of it. So okay. So raise. Oh, I have to remember to do this thing actually. Should have, maybe I should use this as long so I don't have to care about it. Do we do any multiplication? I'll take a look at it for a second. But basically, this is equal to. So basically, we either do this current crime or we don't. So we do it is members minus group index. So that because that's you get. I just have to check that members is greater than or equal to index, because that's how many members you need to use. Then we add this to the new target is that's minus the profit, also profit of index, and then index is just +1 because you already finished this one. And then the other, so that's if you do this crime. So the default is actually you don't care if you do it or not. So you keep the same number of members, you keep the same number of target, and then you just move them. I think this is maybe roughly it. So this is going to be wrong a little bit because I don't consider the mod, but I just want to see. But for the input cases, it seems like I could play around with it for now. Shouldn't return -1 though. Oh, well. It would return -1 always if we don't set it to the answer. Yeah, thanks for asking a question though. I definitely, I mean, if you're having questions about it, I mean, my variable names are not as good as they should be, and I feel like that's something that I need to work on a little bit. But it's always a little tricky with dynamic programming things because like half the stuff is named. I mean, even the numbers they give or the letters that they give you is like G and P, so it's always a little tricky to name these things. At least for me. I mean, maybe some people have issue with it more, but I mean, I could have made it more verbose, like I could call it index of group or something like that. Okay, so this at least looks like for the code one's okay, but now we have to do the math stuff. Okay, and since we're only doing addition, and 2 times this mod is still an int, we don't need to go too long, or a 64-bit thing, but it's still yeah, it's still, you know. But I'm gonna write a helper function because why not? Just to be super safe. I know that you could. There's certain assumptions to allow you to not write some of these mods, but I don't want to worry about it. I'm not gonna try to save one operation sandwich. Okay, that's the one. I'm gonna try something really big. Okay. Oh man, wow, that kind of. Oh, yeah, that's because I used define instead of variable, so it probably was doing was it order of operational things. Okay. Yes. But okay, let's try the big example, I guess, or just 100 members. You want to make, yeah, let's say no profit. So then there are a lot of ways you could do certain things. This is right. This should be like almost, I don't know, 2 to the whatever. Yeah, 2 to the 8. So now we can actually just copy and work this a bit. Actually, I don't care about the profit. So then, just want to check the mod case for overflows and stuff like that. Oh, I didn't add enough because this is just 2 to the whatever. Wait, did I? No, I clearly did not add enough. Okay, so that looks like I modded it because I think that's a power of 2. So let's wait to submit. Let me try one more where the G is 0. And then maybe if the input stuff is 0. Okay. Okay. Let's go. Yay! Oh, and it's really fast. But generally people don't do things in C, so maybe that's just a thing. Okay, 7. Alright, well, I mean, I don't know if you're followers of the stream, will know that I struggle a lot with dynamic program problems, so it's good to, have a win under my belt a little bit and actually get one where I did it in reasonable time, 15 minutes. Yeah, I would definitely explain the code. It's just, you have no idea how much of a relief it is to actually do one where I actually get it right on the first try without, I've been making a lot of silly mistakes today, so I'm just a little relieved and happy about it. But yeah, so this is yeah. Let me go over the problem though. So complexity, right? So time and space. So time and space are both going to be n squared for some definition of n. Is technically because the three dimensions are not correlated, even though they are capped by the same thing. But it's basically the size of g times g times p times the n, which is the number of array elements, yeah, kind of n squared, or sorry, n cubish a little bit. Um, yeah, so that's kind of the space. Oh, sorry, that's the time complexity, and also the space complexity because that part is way obvious. I mean, obvious after you look at the. I mean, we declare the array, so that part is obvious in that sense. But that said, I think so. There's actually a clear what you call it. So there's a clear n square space optimization. So the one thing to note is that uh, and this will require rewrite the to bottoms up dynamic programming. Something that I I generally try to avoid. I don't know if I try to avoid it, but it's not for me. It takes an extra step to get to, like just problem solving wise. So if I was in an interview or something like that, I would generally not do it unless I absolutely need to. And space is one of those things. But one of the things that yes, that's an I need to practice a little bit more. But so one thing to notice in these things is that that you could eliminate a dimension from the space in the dynamic program problem, though you have to rewrite it in bottoms up again. Is that you notice that for one of the dimensions, uh, index in this case, your index always only reference index plus one, and you could actually, and I wrote it this way, but you can actually go the other way as well, right? Like you could actually, because I think this one is symmetric, in the sense that you could actually start with the last job, counting down from n, or n minus one maybe, but from essentially from n to zero, and in that case, if you counted from up to yeah, if you count from higher number to lower number, uh, then you'd actually rewrite this as index minus one, right? I think that's maybe clear, hopefully, because then you go to the now you have five jobs left in the possibilities or whatever, um, and in that world, if you draw it out, and this is three dimensions, so maybe it's not that easy to draw, but you can imagine that because all your index like whenever you're calculating the answer for uh, a particular maybe index is a terrible name for a variable name for that reason, but for a particular index in the matrix, you only need the index minus one. So then because of that, you always only need two copies of the matrix because you only need the previous copy, right? It's almost similar to, I think, one thing. Uh, the analogy is without kind of destroying my code too much, but the analogy is that like the Fibonacci sequence, right? It's kind of the famous case that everyone used. You have like something like this, right? And then you do a for loop, you store, or you do everything in an array, then you do something like f equals f of n minus one plus f of n minus two or something like that, right? And you have this whole array, and then the optimization people always do is you know well, actually we only need the last number, so you have, I don't know, fn, which is a variable, is equal to let's just say you call your variable names like f of n minus 1 plus f of n minus 2, and then something like that, and you can see that you only need two extra variables because you don't need anything beyond n minus 3 and so forth, so you just kind of remove them, right? And then like if you were doing that in a for loop, you would write something like, oh, f of 2 is equal to f of n minus 1, and then f of equal to f of n, or something like that, right? I don't know if you have made that optimization before. If you haven't, there could kind of YouTube's on it. Maybe I'll find a link at some point. But kind of similar to that, where you only need the last, constant copies to calculate an answer. You could also similarly do that to convert this three-dimensional matrix into a two-dimensional matrix to save space. So that's a very long-winded way of saying you could reduce the space requirement from n cubed or g times p times n to just g times p times 2, which is obviously all of g times p. So that's kind of the complexity analysis on this problem. And I'll go over how this happens a little bit. This actually, it's very similar to, in a way, it's similar to, what's it, coin change problem, except for that you're, instead of subtracting from what, yeah, actually, I think that's a better way of looking about it. And I actually did the coin change problem, and I think I tried to explain it, but I don't know if I did that well of a job. But if not, familiarize yourself with the coin change problem. There are a lot of YouTube videos on this, I'm sure, because there's a very fundamental pseudo polynomial dynamic programming problem. Like it, it's in every textbook kind of thing, right? It's one of those problems. But if you think of it that way, then this is just almost like a two-dimensional version of that problem, where you just have to figure out g and the g and the p instead of just one dimension, and you have an index that keep track of two things, or like how it affects two things in parallel, right? So yeah, I think maybe I'm still hand waving a little bit. Definitely ask questions in the chat, and I'll keep on answering them as much as I can. But I think in a way it's a two-dimensional coin change problem now that I think about it like that. And in that sense, like, I think then, yeah, like these two statements are kind of, I mean, I tried to talk through it as I was coding it, because this one I felt like I did get a good grasp in the beginning. But yeah, this is just, like if you did this crime, I feel like I'm gonna be on FBI list, because I keep on, like, so many of these Leetcode problems talk about committing crimes for some reason. I don't get it, but like, can they just be like baking cakes or something? I don't know. Anyway, but yeah, so this is just like, okay, let's say we do commit this job. It costs us this number of members, so our members go from X members to X minus some number, and this costs us and this is just the targeted profit. So now we only need, so we begin the problem needing P profit, but now after doing this job, we only need P minus whatever the input is, profit less, and we go on. And I think one of the trick things that I kind of thought about when I thought about this problem, and one of the things that maybe differentiated a little bit from coin change, is just the base case, right? So the base case is a little bit convoluted, but because they're different, because there are probably different ways to ask this problem in which like the code is roughly the same, the read is the same, but your base case is different. So I think that kind of like, this is what that's what differentiates this from coin change a little bit. So I think I could explain that. So here I kind of actually combine all the states of negative to 0, meaning, okay, so with target is equal to 0, meaning if you need to, like, you even phrase this problem in terms of English, like you need only 0 profit to go on, right? And in that case, you could combine all the negative ones, because all the negative ones mean, okay, we also gain that target, or gain enough to make that target, but it counts, right? Yeah, and that's kind of how we did here. If target is equal to 0, that means at the end of looking through all our jobs, if target is 0, then we have one way to solve it. If not, then we didn't solve this problem, or we didn't have a solution that contributes to the problem, right? So that's kind of how I did about it. Excuse me. Yeah. Oh. I'm looking for where we go. Yeah, there's some stuff about the meta about this that I don't know how I feel about it, but but for me, I don't know. I mean, I just want to get a little bit better on dynamic programming, regardless of I don't know, Leetcode and stuff like that. But I hope I explained this problem a little better. Yeah, I'll take a look at that problem next. But I hope I explained this problem okay. If not, I think actually, yeah, the way I would kind of summarize this for like if you want to study offline, is yeah, read up on coin change and how they kind of structure coin change, both dynamic programming bottoms up and also memorization, which is what I did here for coin change. And then this is just like a two-dimensional version of it. So I think that's so yeah. I think if so, I think that makes it a lot straightforward to understand if you had that hard. Obviously, I also have to just like do some body stuff, but uh, yeah, cool. In terms of difficulty, I mean, I think I actually, even though this is a hard, I actually, and take this as my bias because I actually solved this quicker, but, and having the foresight to know the answer. So maybe that's, I think this is probably slightly a little bit on the harder side. I rather have coin change, like I rather ask a coin change problem that also incorporates another algorithm, like maybe coin change, but then there's like a weird binary search somewhere, rather than like something that's a little confusing. But I think it's, on difficulty for dynamic programming, I think this is actually not super hard for a dynamic programming problem, relatively. But I also feel like it depends on the day of the week, because some days, even for quote unquote easy dynamic programming problems, I struggle a lot with them, so I don't know. Is there, so the question is there any scenario in which bottom up is better than top down? Yeah, so I kind of alluded to this earlier, but in general, not for this specific problem. Um, so, and this may actually come, I don't know if people still ask these kind of interview questions, but like sometimes if you do an interview and they ask you about like general CS knowledge and not like, not the coding part, but they would ask you like, oh, what's the difference between top down and bottom up or something like that. And so my answer to, so it's something to, that's good to know in general because people may ask about that as a CS fundamental question. Even though you might not have to code it. But yeah, I generally, especially looking at problems that I haven't done before, I almost always do it top down. If I do things bottom up, it's mostly because I've seen it before and I already did the optimization before, and and as a result, like like I've done it before, so that's why I know how to do the for loops in a good place. Because I worry a lot about how to do the for loops. But the one that the one advantage of bottom up, and I kind of talked about this actually, especially for this problem specifically, is that in general, if you do things bottom up and you know how to do them bottom up in the right way, you could cut down the memory usage. Like in this case, we have n cube memory, but if we do it bottoms up, you can actually do it in n square space. I mean, it still takes n cube time, but so that's a huge advantage. And also there's some stuff about like there's recursion here, which you know so that, you put stuff on the implicit stack, and there's costs you have to worry about, and one real one is also you have to worry about what's it called, stack overflow, because sometimes maybe you're just doing way too many recursion and stuff like that. So those are the advantage of bottom up that are better than top down. The tough, Eddie, the tougher part for me is that it's just not my intuition way of doing it. But maybe if I practice more on that one, I also haven't, to be to be fair, I also haven't practiced that particular skill very much lately. So maybe if I had practiced more, I could figure that out. Because I think this one, when I saw this to begin with, I almost could have done it with bottoms up, but I am a little rusty, so that's why I end up doing it top down. There are advantages of top down. One is kind of, well, depending on who you are, but for some people like me anyway, top down is easier to understand because you just define itself as a problem as a smaller problem of itself, right? Like recursively. So once you could do recursion, you could do top-down memorization. Obviously, sometimes it takes more space, not all the time, but sometimes. But one advantage of top-down as well is that depending on your problem space, which in this case maybe it doesn't come up as much. Actually, maybe it does a little bit even. maybe. But yeah, an example of that is that so you allocate n cube space. You might not actually need to do all like so. The worst case for this problem is n cube, right? But if you do it top down, you actually don't always hit every state, if that makes sense. What I mean is, let me see if I have a better example. Okay, so let's say for this particular problem, let's say your G is equal to 10, your P is equal to 10. I don't know, you have some group is equal to, I don't know, it doesn't really matter, I guess, in this case. Let's just say 5 ones, and then profit is equal to, and all the profits are 10, say, right? Um, so let's say this is the example case. Then in this case, I think, or I hope that it's obvious-ish to see that like so we allocate all the space for all possible values of p, and if you do it bottoms up, um, you would actually maybe you could have done it slightly cleverer. Depends on how you do the four statements, but I'm making a point, so that pointed me around a little bit. But yeah, like in this case, like you would never hit p where p is like 5, right? Because you're always subtracting 10 from it, so you never hit 5 and stuff like that. And in that sense, it saves you some time because even though the worst case is still n cubed, in a per query kind of thing, like sometimes it just runs faster for that reason, and and not necessarily for this problem, but in some problems that comes up to be more important because yeah, like the world of possible states is way bigger than the number of states that you're actually careful because of either like input constraints or something like that, or like some weird dynamic that like in a problem that that you're given. So that saves you time. So that's another thing that top down buys you. So I think those are the ones that I have off my head. Maybe there are a couple more that someone could point out, and if I miss any, definitely leave chat and comments and stuff like that. But yeah, so that's kind of what I thought about this. But yeah, but I feel like I did okay on this farm for once. But yeah, cool. Yeah. In terms of postmortem, kind of queenness, I mean, I could have done some things slightly better with variable names as usual because I feel like naming things is hard. But I think like the code is relatively clean. I want to say, assuming that the variable names are slightly fixed. But yeah, it's okay. And I got it relatively quick, which doesn't happen enough these days.